All right. Thanks for joining this session about cloud-agnostic design patterns and tips. So basically, we're going to be talking about the cloud. Wow, so cool. um, so basically, in the talk, I'm going to talk about how we can leverage the cloud, but do it kind of in a responsible way, right? By trying to limit the lock-in we have for specific providers, but still being able to leverage everything. And then especially we're going to focus on serverless and a little bit of Java too, because I like Java. So if my clicker wants to cooperate. Oh, wow, it went really fast all of a sudden. All right, so just an introduction about myself. So I'm Kevin Dubois. I'm a developer advocate at Red Hat. Yeah, I like Java, so I'm also a Java champion. And I'm based in Belgium, so if you have any questions afterwards, you can come speak to me, even in Dutch. So that's, I don't know, for the Dutch people here, could be handy. So we're talking about the cloud, right? So, when we talk about cloud computing, and I'm sure you're aware of this, right? So there's some advantages with cloud computing. You can respond more quickly to demand. You can go to the cloud without having to provision and manage hardware and provision servers and creating tickets to create all that. You get high availability, potentially disaster recovery, resilience, right? Because you can use different availability zones and all that stuff. So overall, it's pretty cool, right? You can scale really quickly. When you think about creating an application, it's the same on the cloud as it is on-prem, right? You need to have a platform for your application. So in terms of, you need some developer tools. You will probably want to automate your delivery with some CI/CD tools. You'll need to create some networking if you have more than one application, and monitor logging, all that stuff, right? You need more than just to put an application in the cloud. So fortunately, all these cloud providers, they provide a whole lot of really cool stuff, right? So if you go to AWS and you have this whole menu, this is just kind of a subset, right? They have not just a place for you to deploy your application, but also, in terms of monitoring, you see a whole bunch of stuff there for machine learning, and so really cool stuff. And it's not just AWS, of course. It's the same with Microsoft Azure, with Google Cloud, with IBM Cloud. Of course, I kind of have to mention IBM as our corporate overlords from Red Hat. But anyway, so any of those cloud providers are kind of the same, right? They have a lot of really cool services, really cool ways of working and services around that. But the problem is you get into that ecosystem, but what if now there are regulatory changes? Maybe Google Cloud or Azure or AWS don't want to comply with EU regulations, or maybe the Netherlands has some new rules that don't work for this cloud provider, and you need to move to a different cloud provider. Maybe there are some outages. It does happen, right? I mean, AWS outage or Azure outage. How do you kind of defend against that? What about, like they raise their prices, or a new CTO comes on board, CIO, and their friends, they play golf with the people from another cloud provider, right? There's many reasons why all of a sudden you're happy with one cloud provider, but maybe in the future you're not anymore. And then, you're kind of in a situation where you're using one of these cloud providers and, you're stuck, right? You're locked in. And the migration project is a massive deal, right? So you need to start moving your services to a different provider. They have their own way of doing things, and it's not so pretty, right? So, and this happens all the time, right? I don't know if you've been in this cloud world. I have for a while, even as a consultant, and those migration projects, they're no fun. Basically, for no gain too, right? Because it's the same service. You just have to rebuild the whole thing. So what do we do, right? So maybe you could go for some sort of hybrid and multi-cloud solution. You can use multiple cloud providers, kind of hedge your bets. But then they all do things a little bit differently. So then you kind of need a dedicated team, and actually more than that, you need many people working on this team of Azure, this team of AWS. You know how it goes, right? So while this is a solution for some organizations that want to dedicate their time to this, there's actually better solutions, in my opinion, at least. When I get into that situation, this is how I feel. It's like so of course, there's open source community. There's the CNCF ecosystem, and if you go to the CNCF landscape, I don't know if you've ever gone to their website. They have this really cool landscape with all sorts of services that you can use for working with Cloud Native, and you can actually filter because by default it shows everything. Also proprietary services from specific providers. So here I've actually filtered it down to the actual open source projects that are out there, and there's actually quite a few, right? So this is kind of my go-to to start with when I build cloud applications, using open source, and then if I have to, then I'll go and use some proprietary services as well, because there's always maybe some reason why some cloud provider has a better solution, and that's fine too. I also put Scupper on this. We had a talk about Scupper here just a little bit ago. It's a really cool project to communicate between different applications on a layer 7 across different clouds, across different providers, between on-prem and local. So that's kind of a cool solution, an open source solution to interconnect between different clouds as well. So what about serverless? Because I don't know if you've read my abstract, right? The title said cloud-agnostic design patterns and tips, but actually there was a part cut off from my title. It was actually supposed to be about serverless Java. So I'm going to talk specifically about serverless because this is a particularly kind of thorny issue when it comes to lock-in, because most people, when they start working with serverless, they go with a specific kind of serverless. But before I talk about that, maybe just for those who aren't necessarily familiar with serverless, the idea is that you have a certain amount of load, right? And it fluctuates. You have maybe at some times of the day more load, sometimes less. Maybe you're in the news and you get a big spike of traffic. So how do you deal with that, right? Do you provision a certain amount of capacity for just in case that you get more traffic? But if you look at the left side, all that yellow space is actually waste of resources, because they're provisioned, they're there for when you need it, but you're not actually using them. So the idea with serverless is that you scale exactly based on the demand that's coming in, and so you use only the resources that you need. That's the theory, at least, right? But that's the idea behind serverless. And so when most people talk about serverless, they talk about functions as a service. So function as a service is kind of the initial way of doing serverless and the original idea. So you had AWS or Amazon with AWS Lambda, and you have Azure functions, and you have Google Cloud functions, and so on and so forth. And that works really cool because you just have your code, and you use their tools to package it up, and you push it, and it deploys it all for you, scales it automatically down to 0 if you want, so that it just uses resources when you're actually using it, right? So that's pretty cool. So you have, like I said, if you're familiar with the logos, there's AWS Lambda, the 4 basic cloud providers that I showed earlier. And so in your actual code, right, so if you create a function with AWS Lambda here, for example, you can see, I have my public class handler, which implements this request handler from AWS. So you can see in my imports there, Amazon, AWS, blah, blah, blah. So I'm actually not just locking myself in terms of services, I'm actually locking my code in to this particular cloud provider, which that's not so great, because now if I want to migrate to a different provider in Azure Functions or whatever, it doesn't mean just replacing the services. It's not just our DevOps people that are going to be dealing with this mess. It's actually the developers. And I don't know, in my opinion and in my experience, migrating the actual code is way more expensive even than migrating infrastructure and services. So we want to try to avoid this kind of lock-in. Again, nothing against AWS Lambda, nothing against Azure Functions. Works really great, but you can actually use it, for example, with with Quarkus in a cloud-agnostic way. And you can see, it's not just the functions itself; it's also the services around that, right? So because when you create your AWS Lambda function, then you probably will need an API gateway, and then integrate that with some messaging system. And of course, in the samples, they're like, yeah, use our services, use our messaging systems and everything, which is great, but you're locking yourself in more. So a way that you can do that kind of in a more agnostic way, in a more or less locked in way is, for example, we have an example that just uses HTTP servlet. This is a really basic way in Java to create a service, or you can use this project, this framework called Quarkus. Who here is actually a Java developer? Just so I'm, okay, so we have some Java developers. It's funny, I hear Johan here behind me also talking about Java developers exactly the same time. But yeah, so for the Java developers, this is an interesting sample because this will make sense. If you're not a Java developer, other projects have kind of perhaps similar ways, but I'll talk later about some other projects that you can leverage as well. But in Java, you have this framework called Quarkus, and they have a few ways to work with the different cloud providers, with the functions as a service from specific cloud providers, where you can actually remove those dependencies out of your code and use them just in your dependencies, and then there's a Quarkus extensions that allow you to integrate with these functions without actually putting it in your code. So there's also a funky framework that you can use, and you can see here there's no com AWS or anything in my code, right? So that's a solution for functions as a service, but actually serverless is not just functions as a service, right? You can actually use that same kind of concept of serverless in terms of scaling, right? Auto scaling from 0 down to 0, the ease, the easier way to deploy your application. You can use that concept with containers as well, and so that opens up that whole kind of box a lot more, because now you don't need to deal with specific libraries in your code or dependencies. You can just build regular containers and make those serverless. And so, yes, there are, again, the cloud providers, they also have solutions for this, right? So you have Fargate, you have Cloud Run, you have container instance from the different cloud providers. But yeah, then you might have the same issue, right? Because it's not just a container, then there's the ecosystem around it. So, in this case, I'm not just talking, like about AWS not, or having some lock-in. Is the same with here, for example, Azure or any of the other cloud providers. So you need to be mindful of what you do and how you do it with containers as well. So there's a project out there in the CNCF landscape. So as part of the Cloud Native Computing Foundation, it's an open source project called Knative. And actually, this is a really interesting project. Was anybody in the talk earlier from Daniel over in the... Yeah, so he talked about Knative a little bit as well. This is a project that allows you to use serverless with Kubernetes. So with Kubernetes by default, you can also kind of auto scale, but it looks at the resource usage, so CPU, memory, and so you already have to have a workload running to be able to see what actually resources it's using, right? So it can scale to 0, and with Knative, you can actually scale all the way to 0 because it looks at the requests that are coming in. And so if there's no requests coming in, it's going to monitor it. It's like, oh, you actually don't need to have the service running. I'm going to scale it down to 0. There's no containers being used, no resources being used. And then if traffic comes in, it actually has some back pressure, holds the request for your container to spin up, and it'll handle the traffic. And it actually can scale to more than one, contrary to what Daniel was showing. So Knative can automatically scale from 0 to X based on the request and how you configure it. So Knative is a really cool project to use serverless, to use the cloud resources that you have without the lock-in, because you can run Knative on EKS, AKS, you can run it on OpenShift, you can run it on-prem, you can run it on your Minikube, doesn't matter, right? And so, for example, Knative has, of course, the CLI, because every tool has a CLI, right? So here's some examples of how you could create some functions with Knative. So you have k-and-func create, and then you can supply which library you want to use. So in this case, I use Quarkus, but it could be Node.js, it could be Go, it could be Python. And then it's going to scaffold some code, and then based on that, you can, you usually know what to do, right? You know how to create applications. And then with k-and-func deploy, as long as you're logged into your cluster, if you have your Kubernetes context, it's going to deploy it automatically with auto-scaling and all that stuff. And then, of course, if you want to configure it. So that's an example of using Knative with functions. But again, if you want to use containers, that's perfectly possible too. You just do service create of a specific container image, and it's going to take it from there. So that's serverless containers. But actually, serverless is way cooler if you integrate it with different applications, if you create event-driven architectures, and that's really where you're going to get a lot of advantages from serverless, right? Because, yeah, a function here and there, that's cool, but if they're just kind of standalone, they're not that valuable for the real workloads where we really need, kind of on-demand scaling where we're going to get a lot of gain, right? So that's where there's a lot of new projects out there that are integrating with events and messaging and everything. But again, cloud providers are smart, right? They like to keep you as a customer, so they're going to create specific services for you. But Knative can do it too. So Knative actually has two components. So it has, on the one hand, the serving component that handles the auto-scaling from 0 to whatever, the easy way of deploying. But it has an eventing component too. So you can integrate events, and then it'll look for the requests coming in based on specific event formats to be able to scale. And then it has different components like sources and brokers and triggers that we'll look at in just a second. So Knative eventing is basically a set of APIs to route your traffic, your events from producers to consumers. And then there's another CNCF project out there, which is cloud events. And this is really interesting too. It recently actually graduated as a CNCF project, which means, kind of, hey, this is actually, according to the CNCF, a fairly mature project that is, kind of really good to use for the enterprise. And Knative can actually leverage this. Google Cloud actually supports this as well. So you can use Google Cloud Functions with cloud events as well. So the idea is that this is a specification to describe an event. So as kind of by definition, you supply an ID, a source, and a type of an event. And so your consumer knows exactly how to handle a specific event that you've sent. And so it supports those, it's protocol agnostic, right? So you don't have to deal with specific protocols like HTTP or AMQP or MQTT or whatever. So the pattern, of course, is kind of, you have a source, and then you have a sink. A sink is what handles that event. And then, so with Knative and cloud events, you could create a system like this, right? So you have a source, you send it through a channel which actually handles the events and can forward them to one or multiple consumers. So if you're familiar with kind of traditional messaging systems, you'll see that this is fairly similar, right? The only difference is here you're actually leveraging Kubernetes custom resources, cloud resources and you're not locking yourself into a specific messaging system that is hard to maintain and that you have to deploy kind of separately. So this can all happen just on Kubernetes. So you can use a channel that's going to be able to send the traffic to different consumers if you want. There's also the concept of a broker and a trigger where you can actually send events to different consumers and they can filter in which events they're interested in or not. And what's also interesting with this concept is that this channel and this broker, you can back that with persistent messaging from, for example, Kafka. So you can put a Kafka topic behind this. So you can create really sophisticated event-driven systems that scale up exactly when events come in, scale back down if there's nothing coming in. And yeah, you can do this all with open source, which is pretty cool. So I put a question mark with the demo because I wasn't sure if I was going to have time, but I think I actually have a little bit of time. So let's take a look at this. So this is a very kind of simple system that I've created. I'll first show it. So I have this demo, and you get to vote which is your favorite IDE. So people are usually a little bit opinionated about that, so we'll see who wins here. But basically, the way that I've created this, and yes, I've completely over-engineered this on purpose, of course, but you have a UI. You can vote for your favorite IDE and actually vote as many times as you want. I don't care. It actually is cooler if you vote multiple times. We're going to have something that listens for those events from the UI. It's going to send them to a Kafka topic, and then my processor at the end is going to listen for those from those events from Kafka in this case, put them in a database, and then my UI is going to read it. And apologies, I know that there's a lot of front-end people here. I'm terrible at UI, so keep that in mind. And then just to show you here, this is what is deployed. So I have the UI, and there's no blue circle around this. There's no blue circle around this ingester, which basically means it's not using any resources right now. There's no pods actually running for this, So you can see here, auto scale to 0. So I'm going to share this QR code and see if you can scan it, and then you should be able to vote for your favorite IDE, and we'll see who wins. Is there anybody here from Microsoft that is working on VS Code, or from JetBrains that is from IntelliJ? No, okay, good. All right, so start voting, start clicking. And in the meantime, I'm going to show you that, oh, look, there's a blue circle around this, and we already have 4 pods running. So it already scaled up. It saw that people are clicking, and it scaled up some resources. And if anybody has a laptop and wants to automate this and wants to start bombarding me with requests, that's great, because then we'll just see that it's going to scale up more. Or if you stop voting, then of course, then it's going to scale back down to 0 and not use any resources. So which we can see, terminating. So we can see that less people are voting, and it's like, well, we don't need all that demand. So let's take a look at our votes and see who's winning here. So we got VS Code is in the lead, closely followed by IntelliJ. We got some Vim users. And oh my God, there's almost no OpenShift dev spaces. What? So if I had more time, I'd actually run a little script to send like a couple million votes to OpenShift dev spaces, because why not? And then I would win. But that'll be for next time. But anyway, I hope this was interesting to see kind of how you can leverage open source cloud native resources without really much lock-in. So I was using a Kubernetes. Yes, it happened to be OpenShift, but OpenShift itself is open source too. But you can actually use Knative with any Kubernetes. So quick word about AI, of course, because we have to talk about AI in every talk these days, right? So you can leverage serverless and AI really well too, right? Because maybe you want to create a model that scales up, does a bunch of work to create the resources, all the the inference of the data and everything, and then scale back down. So there's a bunch of use cases with AI and serverless. So it's a nice marriage of the two kind of hot topics. So you can see there's a link from the Knative project itself with a case study of a particular company that is using Knative with AI. So if you're interested in that, definitely take a look at that. And then just to wrap it up, so cloud providers, they provide a lot of really cool stuff. I'm definitely not saying don't use it. I'm just saying be mindful of cloud lock-in. Even if you think that we're 100% confident in AWS, in Microsoft, or whatever, hedge your bets. Be mindful of one day that might change. And then in terms of serverless, hopefully you saw that serverless is a lot more than just function as a service. And use open source when you can, but use proprietary services, of course, when you must, right? I mean, there's always some use cases where it makes more sense, and yeah, you can be like very kind of, I'm only using open source and I'm very much in that boat, but I know very well that sometimes that's just not feasible. And then if you do use open source solutions and say, well, actually, this service from this cloud provider is way better, well, let the maintainers of those projects know and maybe contribute too, right? I mean, we're all in this together. If we could create something together, then the cloud providers, they will come along, right? If you look at how the landscape has changed over the last few years, there's a lot more focus on Kubernetes versus before. They all had, kind of their own systems. So open source does win if we all play along with it. So real quick too, so the developers.redhat.com, so of course they're my employer, but they sponsor a bunch of books and make those available for for people to download. And so it happens to be that my colleague Daniel, who spoke earlier, and I were writing a serverless Java in action book, which isn't available there yet. But we're hoping that Red Hat will sponsor that one too, and then it would be available there. But definitely keep an eye out for that. If you follow me on Twitter, then you'll know when that becomes available. And if not, give me a follow anyway, because I would really appreciate it. And let me know what you thought of this session. If you liked it, post it, publicly. If you didn't like it, just send me a private message. Just kidding. All right, thank you.